All right, let's move on then. So here we go. Problem number 5, which I guess is our first real question here. Most of these, even if you don't remember the technical mathematics of this stuff, you could probably reason your way through this given the scenario and the fact that there's graphs to identify what's happening. So it says match each description of the situation with its corresponding graph. Explain your reason. So a person gives $20 a week to a friend to repay a $200 loan. Quick question for you. If you're paying off a loan, does your loan amount increase or decrease? So if you borrow $200 and you're paying back $20 a week, would the amount of the $200 loan increase or decrease? It's going to decrease, right? If you borrow 200, if you pay off that 200, the amount that you owe, that 200 will be decreasing. So chances are we're looking at B or D. I think the starting value here kind of indicates which one it is. Which one do we think? I'd say B. Yeah, that makes sense. So, by the way, if you think about it this way, it's going down $20 a week, which means over 2 weeks, it'll go down by 40. And I'm trying to think of a good way to say this, because as we go down here, that right there is not a perfect cross at 150, but it goes across a little bit higher than 150, which is actually probably a good way to figure this one out. Because this right here, this vertical line here, this value of X is 2. So that represents 2 weeks. So if you're paying $20 a week, that means in the first 2 weeks, you're paying $40, right? First week is 20, second week is 20, total of 40, which means you still owe 160 out of the 200. And that line crosses just above the 150, right about 160. So it kind of stands to reason that that would work. And it looks like it's being paid off over how many weeks total? 10. So 10 weeks, $20 a week, $200 total. Yeah, I'd say B for, so let's see, how are we going to match this? I'm going to just go with capital B after that. Probably the easiest way to do that. I don't like that they use the same 4 letters, capitals and lowercase. That's not awesome. But graph capital B matches with scenario lowercase a. All right. Scenario B, an employee receives $12.50 an hour plus $2 for each unit produced per hour. Earning money. Is that going to be increasing or decreasing? Increasing. Okay. So we're looking at graph A or B. Which one seems to start at an hourly rate? So basically, we're talking about money that you could potentially earn in 1 hour. This is not multiple hours of work. This is employee per hour plus each unit, $2 for each unit produced per hour. So this is potential earnings in a single hour. Which one of those would it be, A or C? C, right? Because it's starting at $12.50. So the base salary is $12.50 an hour. And so if the person produces, 6 things in an hour, it looks like they're going to be earning $25, roughly. If they produce 8 things an hour, that'll be like, I don't know, maybe about $28. I mean, we can figure it out by doing the math, but this graph definitely matches with scenario B. So capital C by scenario B. All right, we got 2 left. A sales representative receives $30 a day for food plus 56.5 cents for each mile driven. So $0.565 would be 56.5 cents for every mile driven. Basically, we're starting at 30 and we're going up. So that's graph A. And then the last one, a computer that was purchased for $750 depreciates $100 a year. So that one's definitely going down. Find a starting value of $750, roughly. That would be graph D. So like I said, even if you don't remember exactly how to do all this stuff that we're doing today, this first one, you could probably reason your way through and kind of figure out what's happening, just based on the numbers themselves. Because every starting value was different. So all you got to do is match the starting value for each one. All right, flip it over. So we're going to be looking at Basically two main ways of representing a linear equation today. We've got slope-intercept form and we have point-slope form. Slope-intercept form is by far the most commonly used one. Point-slope form is a little bit different. And it kind of looks similar to a lot of the stuff that we were dealing with last week, actually. So if you are given the slope, which would be your rate of change over a certain amount of time or whatever it is, rise over run, that would be your value of m. And the y-intercept is wherever the line crosses the y-intercept, and that would be basically your start value in most of these scenarios. That's your value of b. Could be positive, could be negative. Same with slope, could be positive, could be negative. In terms of point slope, does anybody remember this function here? Or yeah, go ahead. Here. What's that? Yeah, b is the y-intercept. It's the point where the line intersects with the y-axis. So like on this graph here, b would be 18. Yeah. Or on the front, for graph A, b would be 30. For graph B would be 200. For graph C would be 12.5. Graph D, B would be 750. And then for point slope, you are still provided with the slope, but you are not provided with the y-intercept. You're given some other value, some other xy coordinate aside from the actual y-intercept, which is why it includes an x and a y value. The reason why we don't use an x and a y value for the y-intercept is because the x value is always the same for the y-intercept. Like if you take a look here, what's the x value for this y value of 18? What would the x coordinate be? 0, right? Anytime you're going straight up or down on the y-axis, you're not going left or right at all. So this would be the point 0. It shows right here, 0, 18. So 0 is the x value, 18 is the y value. The y-intercept is wherever your x value is 0 because it means it's on the y-axis. So we don't include the point here because x value of the y-intercept is always 0. However, if it's another point on the graph, we need to make sure we include that. And by the way, x and y in both of these equations basically mean any value of x or any value of y. And they always remain x and y. We don't ever necessarily plug in numbers when we write those equations. However, with x1, y1, x1, y1 is just the specific point value that you are given. Whatever coordinate is given on your graph, that will be x1, y1. And those values go in for x1 here and y1 here. All right. So if you are given points, you will be writing probably a point slope equation. But if all you are given is 2 points and nothing else, you first have to figure out the slope of the graph. So we do not have the slope formula anywhere on here that I can tell. So let's just write this. M equals, this is our slope formula. Go ahead and write this right here. Does anybody remember what the slope formula is? We know it's rise over run, right? Does rise indicate up and down or left and right? Up and down, right? So that means that with the y values or the x values go on the top if it's rise on the top. The y values are on the top. And if you're finding the difference, basically it's the difference in the y values. So that would be y2 minus y1 over the difference in the x values, which would be x2 minus x1. And then if it's a fraction, simplify the fraction. If it's a whole number, you can write it as a whole number. So you find your slope, and then you can write your point slope equation after that using one of those 2 points in point slope equation. We'll see what that looks like. So quick review stuff over on the side here. So if you're using problem solving, basically, if you have a word problem, that's generally what problem solving indicates. First of all, it's important to understand the problem. What is the situation? What are you being asked to find? You can't figure out the answer if you don't know what the question is, right? Always figure out what the problem is actually asking you to figure out. That way you can actually make a plan to solve for that thing. And then, yeah, make a plan. What's your strategy? Try to work it out in the best way you can. Are you going to be using, in this case, slope intercept? Are you going to be using point slope? What's going on here? And then you're going to solve the problem and then review your answer. Does it actually make sense? Does the number I have make sense with the scenario? Can I plug it in and double check with the algebra, make sure everything works? You know, things that you've probably been told 1,000 times in terms of problem solving in math. But it's always good to have reminders. So, example 1. writing a linear function or a linear equation based on a graph. So here we go. The graph shows the remaining balance on a car loan after making X monthly payments. Write an equation of the line and interpret the slope and the y-intercept. What is the remaining balance after 36 payments? And then challenge. What is the domain in the range? We'll do all of that. So you're going to take your inventory. First thing we need to do is figure out our slope. That's what it tells us right here. So it's going to guide you through this one. Find the slope. All right. So we should probably go ahead and use the slope formula if we're finding the slope. And we have two coordinates here. So I'm going to call the top one x1, y1. And we'll call the bottom one x2, y2. By the way, the ones and the twos don't actually go next to the numbers. They're like down a little bit and to the right of the numbers. If you write them up, obviously that's exponent form, but this is called subscript. So you might hear me say sometimes like x sub 1 and y sub 1. That just means the same thing here. You write a little number down a little bit lower to the right of the variable. All that means is the first x value and the second x value. 0 is the first x value, 10 is the second x value, 18 is the first y value, 15 is the second y value. It's just differentiating between the two different x's and y's. I'm sure some of you know that, or all of you. But like I said, reminders are never bad. All right, so slope, here we go. M equals the value of y2, 15, minus y1, 18, over x2, 10, minus x1, 0. By the way, as you look at that graph over there, is the line going up or down? Down, okay. So would that indicate a positive or negative slope? Negative, okay. So whatever we get here should be a negative number because that slope is going down, therefore it's a negative slope. So little things like that to kind of check your progress throughout the problem. Like if this ends up being, if you solve this and it ends up being a positive number, that doesn't work with the visual. So something over here needs to change. 15 minus 18 is negative 3. 10 minus 0 is 10. I think that's our slope because that doesn't reduce. So what we're looking at is rise over run. Basically, that means from one point to the next, go down 3 and over 10. And that'll get us to an exact point on our graph. All right. So, which actually makes sense, because if you look at the scale here, if we go from 18 down to 15, that's a decrease of 3 on the y-axis. And from 0 to 10, that would be an increase of 10 along the y-axis. So down 3 over 10, down 3 over 10. And you can see that that happens because the scale on the y-axis is 3. So we go down one grid line, that's basically going down 3. And then if you go over 2, that would be 10 on the x-axis. So there's our next point. Down 3 over 10, there's our next one. Down 3 over 10, there's our next one. It is not a slope of negative 1/2. So that would probably be the most common error in terms of slope, because if you count the grids, you go down 1 over 2. But that does not match up with the scales of those numbers. So just be really careful about that. If you're using the actual graph to figure out your rise over your run, know the scale before you start counting. All right, slope, negative 3/10. The y-intercept, what is the y-intercept here? What does b equal? 18, yeah. It actually shows us our y-intercept as one of the 2 points we were given. So nothing to calculate there. So b equals 18. What does it say? Write an equation of the line and interpret the slope and the y-intercept. So not only do we have to write the equation, we have to say what those things mean. So let's write the equation. Since we have a value of m and a value of b, we should probably just go ahead and use slope-intercept equation because those use m and b. So that would be y equals our slope, negative 3 over 10x, and then our value of b, which would be plus 18. So there's our equation. Y equals negative 3/10 x plus 18. That's our slope-intercept equation. What do those things mean in this problem? Take a look at the graph real quick. What does our y-intercept mean? Here. Okay. In terms of the scenario, though, we're talking about a car loan, how much money is owed, and then how many payments have been made. So specifically in this context, what does our y-intercept actually mean? What's that? Yeah, the initial amount of the loan, he borrowed $18,000 to buy the car. That's what that means. Everybody see that? So the number is 18, but if you look over here, it's the balance. That's how much money is owed in thousands of dollars. So 18,000 is how much money was borrowed to buy the car. So it says interpret the slope and the y-intercept. So we're going to say y-intercept. Let's see. $18,000 was initially borrowed. This is an $18,000 loan to purchase the car. That's what we can gain from that y-intercept. How about the slope? What does the slope mean here? -3/10. What's that? So it definitely helps us figure out the number of payments. Number of payments is just the X value. So if we give down 3 on the Y, we go over 10 on the X. So that relates the amount of money that he still owes, or he, or this person, doesn't say he, the amount of the money, how amount of money the person owes versus how many payments have been made. But what can we actually learn from that, Mary? Yeah. So it's more about how much money is left on the loan, right? Versus the value of the car. Okay. So what does it tell us then? Okay. How much it goes down by over the number of payments. I agree with that. Can we maybe get a little more specific with that, lady? Every 10 payments, $3,000, or yeah, every 10 payments is paying off $3,000. Okay. How often do you usually pay a car payment? Do you know? What's that? Every month. Okay. So that is probably what we should be looking for here. Is what is the monthly car payment? So if it's $3,000 for every 10 payments, or $3,000 for every 10 months, what's the monthly payment? Come on in. Yes.
Yes.
I have Gabby. I don't have
Can-
Arnold.
No.
No, just Gabby. Yes. Gabby, right here.
Take your photo and take a picture.
For sure. Yeah. Go for
Yeah.
it. So go ahead. Anybody figure out the car payment? Yeah, $300 a month. Yep. Because if it's $3,000 every 10 months, just divide 3,000 by 10, right? So the slope indicates $300 a month. $300 a month for the payment. There we go. So the car payment, $300 a month, which I don't know, it seems like kind of a standard car payment, roughly. So that's what the slope and the y-intercept mean in this particular problem. So that's what it wants you to do. It wants it to break it down and be as specific as you can with what those things mean. Because if you're having a conversation with someone about, hey, I just bought a car. you know, and sometimes you talk about like the cost of the car and maybe how much money you borrowed in order to buy the car and like what your monthly payments are. That's the kind of stuff you might actually talk about. I doubt that if you talk about buying a car, you'd whip out a graph and be like, hey, check this out. You know, usually it's more conversational than that, right? So let's see. We got a couple more questions. What is the remaining balance after 36 payments? All right, so we could do one of two things. We could try to find out where 36 is on here. Not really going to be an easy thing to do because the month's number of payments is going up by 5 each time. So finding 36, probably not. So if we wanted to figure that out, what would we do to figure out how much money is left to pay after 36 months? Any thoughts on that? What's that? Yeah, use your equation. Number of payments down here, that has to do with the x-axis, right? So if number of payments is 36, that means in our equation, x is 36. So take 36, plug it in for x, and then solve for y. That'll give you the remaining balance after 36 payments. So after 36, I'm just going to say PMTS for payments. We're going to say y equals -3/10 times 36 plus 18. And let's see. What do we get? I got a decimal. Somebody else get a decimal? What's that? I got a smaller number than that. Mary, I think I saw you mouth it. What was it? 7.2, yeah. Is that how we should answer this question? Y equals 7.2? Like if somebody asks you, or if you're telling somebody how much money you have left to spend, or how much money you have left to pay on your loan, and you tell them y equals 7.2, they're gonna look at you weird, right? What would you say then? How much money is still owed? What does 7.2 mean? What's that? It's a little simpler than that to figure out the number. What does y represent? It's the balance in what? Thousands of dollars. So multiply that by 1,000. 7,200, yeah. So remaining balance is $7,200. After 36 months, $7,200 remains. Okay. Last question, challenge question. What are the domains and the ranges here? All right, I'll be real quick with this for domain and range because it is a challenge question. We don't need to worry too much about it. So we're going to say D. What is the largest value of the domain? What's the largest X value here? How high does it go up along the X axis? Like how many months is it going to take to pay off the car? 60, right? Okay. So largest value is 60. What's the smallest value? 0. X is in between. So we have ourselves basically a compound inequality where the value of X is less than or equal to 60. 60 months is when you pay it off, but it also has to be greater than or equal to 0 because that's when you got the loan. So number of months 0 is when you bought it. Number of months 60 is when you paid it off. And then anything in between that could be a value of X. Likewise, we're going to do something really similar with our range. What's the maximum value for the range? 18,000, yep. So let's use 18,000 and not just 18 because we're talking about thousands of dollars there. That's how much was borrowed. How much money do you owe when you pay it off? Like once it's paid off, how much do you have owed? 0, okay, nothing left. So same thing as what we had there, less than or equal to, less than or equal to, because the value of Y, the amount of money that you owe, is either $18,000 or $0 or any value in between that. depending on how many payments you've made. So those are our domains and ranges there. All right, second page, here we go. Any questions on that before we move on? All right. Here we go. Next page, we have ourselves graph B. Use the graph to write an equation of the line and interpret the slope of the y-intercept. And then your challenge is to find the domain and the range. So I want you to do this one on your own. And I'm going to give you, I'm just going to say like 3 minutes to start off. See what you can do in 3 minutes on this. And you may or may not need to write a point slope equation for this. Yeah, go for it. Go ahead and take pass. Right here. Yeah. Alicia is up next as soon as she gets back. Okay, let's have a look. So with our slope here, the slope is 1. If you take your 2 points, y2 minus y1 over x2 minus x1, that'll be 95 minus 85 over 20 minus 10, that's 1. Slope is 1. In order to actually write the equation, though, you're going to have to start with a point slope equation because we don't have anything in terms of our y-intercept yet. So what you'll need to do is write your y minus y1. So the point slope equation was y minus y1 equals m, and then parentheses x minus x1. Something like that. So what I did is I used just the first x and y values and plugged into that. I took 10 and 85 as x1 and y1. And so I wrote y minus 85 because it was y minus y1. 81 I said was y1 equals. I didn't use my value of m here just because m was 1. But if you wanted to, you could put 1 and then parentheses and x minus 10 inside. That's fine. You would generally have to do that if your slope is something other than 1. So 1, and then if you distribute the 1, it's the same thing. And then I just solved it for y in order to get it into slope-intercept form. So from y minus 85 equals x minus 10, I just added 85 to both sides to get y by itself. And that gave me y equals x plus 75. That would be the slope-intercept equation. So use point slope and then solve for y basically. Any questions about that? So you plug in a point slope, convert to slope intercept. Slope is 1, y-intercept then is 75. Now, in terms of what this means, it means that this is a really weird grading system for whatever class this is. Because if you look over here, it says completed assignments 0, right? And then homework grade percentage. So even if nobody completes a homework assignment, there's still like a pretty high grade for homework, even if no assignments are completed. I'm guessing a lot of people wish the grade was like that in most of their classes, but that's probably not the case. What this actually means is this starts at 75 because that's our y-intercept, meaning the y-intercept means you get a 75% on your homework, even if no assignments are complete. It's a little odd. I'm gonna say, I'm guessing plenty of people wish that we did that. The slope then, slope of 1 means up 1 over 1. So that would be an increase of 1% for every single assignment completed. So basically, in order to get 100%, you would need to do 25 assignments. What's that? Yeah. 3 points. All right. So that's what that means. Domain and range. I mean, the domain and the range could be a little bit interpretive because maybe they cap it at 100%, but maybe they don't. If they cap it at 100%, then the domain would be between 0 and 25, and the range would be between 75 and 100. If they don't cap it, then it would just be, you know, greater than 0 for the x's and then greater than 75 for the y's. But we don't need to worry about that. All right, next one, modeling with mathematics. Any questions on that before we continue? All right, let's keep going. It says 2 prom venues charge a rental fee plus a fee per student. The table shows the total cost for different numbers of students at Lakeside Inn. The total cost Y in dollars. So here's the dollar amounts here. For X number of students at the resort is represented by the equation. Oh, they give you the equation. That's nice. Y equals 10x plus 600. Which venue charges less per student? Oh, wait, Sun, no, they give you 1. Sunview Resort is this right here. And then you have to figure out Lakeside based on the table there. Which side charges the less per student? And then how many students must attend for the costs to be the same? All right, so let's go ahead and figure this out real quick. So it gives you the amount of money here for Sunview, so we don't need to worry about that. But Lakeside, we got to work on a little bit. So let's see, Lakeside. All right. In terms of slope, you can choose any 2 XY pairs here to figure out the slope. It doesn't matter which ones you pick. So I'm just going to choose the first 2. So 100, that'd be X1, 1500 be Y1, 125 is X2, 1800 is Y2. That's what I'm going to go with. So I'm going to say M equals Y2, 1800 minus Y1, 1500 divided by 125 minus 100. So that would be 300 over 125. And let's see, 300 divided by 125 is 2.4. So, oh, sorry, 25. 25. So that would be 12. 12, not 125. 125 minus 100. Okay, slope is 12. And then we got to choose one of these coordinates as well to use with our point slope equation, because we need the slope intercept form eventually, but we don't have anything in terms of y-intercept yet. So I'm just going to use the first point here for point slope. And again, it doesn't matter which of these points you use with point slope. It makes no difference at all. You'll end up in the same place either way. I'm just going to pick 100 and 1500. So we'll do y minus y1, which is 1500, equals the slope of 12, and then times in parentheses x minus x1, which would be 100, so x minus 100. So there's our point slope equation right there. Let's go ahead and just distribute the 12 and then get y by itself. So we'll multiply 12 by x and 12 by 100. So that would be y minus 1,500 equals 12x minus 1,200. And then to get y by itself, just add 1,500 to both sides. So that'd be y equals 12x plus 300. So that's our Lakeside Inn slope intercept equation. Sunview Resort, y equals 10x plus 600. Basically what we're saying is that Sunview charges $10 per student and Lakeside charges $12 per student. So which venue charges less per student? Sunview. Okay. So less per student would be Sunview. All right. Now, the what is it? The rental fee is less for Lakeside than it is for Sunview. The rental fee for Lakeside that we just figured out is $300. And the rental fee for Sunview is its y-intercept, which is $600. So it's double the amount for the rental fee between Sunview versus Lakeside. So depending on how many students show up, one might actually be a better value than the other, even though one charges less per student because one has a higher rental fee in the first place. So what we need to do is figure out how many students have to attend for the cost to be the same. So let me ask you this, between X and Y, which one is cost? Y is cost, right? So I'm going to write Sunview right underneath here, 10X plus 600. This Y and that Y, they both represent cost, don't they? That means they're representing the same number, which means that if the costs were going to be equal, that means that 12x plus 300 would be equal to 10x plus 600, right? Okay, so that's our equation. 12x plus 300 equals 10x plus 600. The cost for Lakeside is the same as the cost for River or Sunview over here. And now we just have to figure out X. X would be the number of students. So subtract 10, that would be 2x. Subtract 300, that would be 300. Divide by 2, and X equals 150. So how many students need to attend for the cost to be the same? 150. So 150 students attend for cost to be, just to say equal. 150 students need to attend for the cost to be the same. Cool. All right, we're getting close to being done here. Questions on that one? You guys have done stuff like this before. Just kind of getting back in the swing of it. All right, let's go and flip that over. Do a little bit more here. All right, now this last part, we're we're gonna be talking a little bit about a line of best fit. Again, this is something that I'm sure you've all done before, but maybe not as specifically as we're about to do it. And I got a few more minutes to show you. We're gonna do a little bit of Desmos work with this as well, just very quickly. So, and there's a video demo for Desmos as well, which is actually really nice. So, if you kind of need an example about how to get this done on Desmos, which is what you're gonna need to do because those graphing calculators need to stay here. Line of best fit, basically, if you have a string of information points on a graph that don't quite line up perfectly, there is a way that you can demonstrate the best way to draw a line through those things. A lot of time, you're probably used to just being like in Algebra 1 anyway. What we did was, okay, get a ruler, try to line these up as best as you can, and then draw a line that kind of keeps the same amount of points above it as below it. And then you can pick a couple points from your line and write your equation. That's generally what you do in Algebra 1. However, here, I don't even really see grid lines over here. That's not super helpful. But here's our information. Clearly, this is not a linear set of data because if it was linear, they would all perfectly be in a line. And so what we're trying to do here is you are going to be working on Desmos to do this type of stuff here. And in terms of a correlation coefficient just basically means the line that you've drawn, how well does it fit the information that's there? If it's a -1, that's a strong negative correlation. If it's 0, that means there's no relationship between the points at all. And if it's a +1, it means a strong positive correlation, which is what we're going for here because we're looking at positive slope here because it's going up. So we're looking for an R value really close to 1. The closer it gets to 1, the more in line your line is with the data. And so what you're going to end up doing is you're going to end up making a table on Desmos, and I'm just going to actually I'm going to have you check that out on your own. So you can either use the QR code and scan it, or you can type that website into your Chromebooks to work that out. But basically, it's going to have you enter this information into a table, and it's going to walk you through how to get that equation written in there. And all you have to do once you have that in there is Desmos will tell you what the equation of the line is, and it will give you the correlation coefficient, and you'll just write those two things down. So, and then you're going to use the equation to predict the height of a person if the femur was 36 centimeters long. Femur length is X, so you just plug in 35 for X into your equation, and then solve for Y. So that's all you need to do for that. If there end up being questions on this, if we need to go over this stuff tomorrow first thing in class, in case people are having trouble with the Desmos side of things, let me know. I'm happy to go over it. But there is a demonstration video on how to make that happen. So all you have to do is just follow those directions. Should be pretty straightforward. Like I said, if it's not, we can certainly go over that. But I wanted to make sure you had a little bit of time just to at least look at some problems before we go. Because I think we're out of here at today's regular. Yeah, 10:31. So we got like 4 minutes left. By the way, I will actually write in the correct assignment today on Google Classroom. I'm actually going to write the same problems that I did for 1.2 in Google Classroom because I accidentally wrote 1.3 through 1.2s the other day. So these are your problems that you'd be working on. I'll be careful to make sure I do that correctly. Tomorrow, by the way, tomorrow we're just going to skip ahead straight to 1.4. That will be our last lesson for this unit, solving linear systems. Which you've done before. You solved systems of 2 equations before. We might be getting to 3 equations, we'll see. And then we will review on Thursday and we will test on Friday. So we will get you ready for that on Friday. You'll be able to put together your page notes and all that. So feel free to get packed up. If anybody needs any materials from me that you haven't gotten yet, let me know.